Morning and welcome to mathsatoka online class. Today we'll be talking about frictional force. Okay, and frictional force means opposing force. Okay, if you are drawing something this way coming close to you, so there is a force that is pushing it backward. That force is called a frictional force. So if I'm pushing this force this way, I am applying a force. Fa means applied force. I'm applying a force for this body to move this way. This body is in contact with this plane. Okay, and then if I'm pushing it this way, there is a force that is pushing it the other way, and that force is called frictional force. Okay, we have two types of force, frictional force. We have the static force, the static frictional force, and the kinetic or dynamic frictional force. The static frictional force, we equally call it the limiting frictional force. It is the maximum force that must be overcome before a body can just begin to move. Okay, there is a force that has to be overcome for a body to begin to move. So that force is called the static frictional force. Then for the kinetic or dynamic frictional force, is a frictional force that must be overcome so that a body can move with what? Uniform speed or uniform velocity, okay, over another body. So you need to know the difference because it's an exam question. Then the laws that are guiding any frictional force. Okay, laws of solid friction. The first one said that friction opposes relative motion between two surfaces in contact. Okay, so the second one said frictional force increases in the same extent as the force which tends to start the motion. Okay, thirdly, they said that frictional force depends on the nature of the two surface in contact, and it's true. So if it's a rough surface, the friction will be much, so it depends on the surface. So the next thing is what? It is independent of the area of the surface in contact, so it does not depend on the area. Okay, then the next thing you need to know is that frictional force is directly proportional to the normal reaction. Frictional force is directly proportional to the normal reaction. That is the most important thing I need you to know here, that frictional force is directly Fr. Frictional force is directly proportional to this normal reaction. Okay, if we now remove the proportionality sign, we have that frictional force is equal to what? Mu r. Okay, where mu is called the coefficient of static friction. The coefficient of static friction. So if you want to get the coefficient of static friction, you say that it is what? Frictional force over the normal reaction. Okay, so note that. Now another thing you need to know, for this object to move, this is an important formula, very important formula. Another formula you need to know is that for this object to move, okay, the moving force, look at it, the moving force is equal to ma, mass times acceleration, which is going to move, and is equal to what? The force applied minus the frictional force. So for this object to move, the force applied must be bigger than the frictional force. So if you now subtract it, the remaining force is the force which that body used to move. This is a very important formula, very, very important formula. Okay, that's what? The moving force for a body to move, that the applied force you must subtract what? The frictional force. Very important. You need to know the advantages of friction. It helps us to walk, and so many of them, you can read it up. Disadvantages of friction: wear and tear. That is what make you change your shoe. Okay, it's because of friction. Then how to reduce friction? You apply lubricants, or you use ball and rolling beer, and so on and so forth. So let's take question. We are here to calculate. So let us start our calculation. Number one, the first question here said they gave us a body like this. Okay, they said that this body has a weight. This is the weight of the body, and this is the normal reaction to the body. They said that this one is the frictional force of the body, and this one is what? The applied force. Okay, now they now said in the diagram illustrated, okay, so the diagram above illustrates a body of mass 5 kg. So they gave us the mass of this body, which is 5 kg. I want to be reading it out, so you'll be writing it yourself. Okay, being pulled by a horizontal force F. They pulled it with a horizontal force F. Okay, so okay, let me just write exactly what they wrote. They said that here is F. They said that here is F, and here is F1. So they said that it is being pulled by a horizontal force F1. So which means the F1 is the applied force, okay? Call it applied force. They said it's being pulled by a horizontal force F. Okay, F. Sorry. It's being pulled by a horizontal force F. So we are putting it this way. So that is the applied force. They now said if the body accelerates with a acceleration of if the body accelerates at 2.0 meter per second, the acceleration is what? 2.0 meter per second, okay, per second square. Let me start afresh. They said the diagram above illustrates a body of mass 5.0 kg, comma, being pulled by a horizontal force F. Please write it down, okay? Full stop. If the body accelerates at 2.0 meter per second square and the frictional force of 5 Newton and a frictional force of 5 Newton. So they gave us the frictional force there. F1 is the frictional force, which is what? FR. I like calling it FR, which is what? 5 Newton. 5 Newton. Okay? They now say the one I question. They said calculate the net force of it. Calculate the net force on it. The net force is the moving force, the force that will allow it to move. Okay? The net force on it. Okay? So the next one, I, they said that we should calculate the magnitude of F. That is the size of the frictional force, that's of the applied force, magnitude of F. Then the last thing they say we should calculate is the coefficient of kinetic friction. Coefficient of kinetic friction. Okay? Now, it's a very simple thing to calculate, so let us go. Now, first of all, for a body that is sitting like this, okay, the weight of that body is equal to the normal reaction. Okay, first of all, let's start from number one. Number one says we should calculate the net force. The net force is the applied force. And the applied force is always, the moving force. The moving force is always ma. It doesn't change. Which is what? The mass 5 times the acceleration 2, which will give you 10 Newton. This is what? The moving force. Okay? So the next thing they say we should calculate is what? The applied force, II. F, which is equal to the applied force. And the applied force, how do you get the applied force? We know a formula that said that what? That the moving force is equal to what? The frictional force minus what? The applied force. Sorry, the applied force first minus the frictional force. Okay? So we can get that. They have given us the frictional force. So the moving force is 10 is equal to the applied force is what I'm looking for minus the frictional force they gave us as 5. So if I collect like terms, I'm going to have 10 plus 5 is equal to the applied force. So which means the applied force is equal to what? 15 Newton. Okay? The applied force is 15 Newton. So the next thing you need to know is that I. Let me clean here. Okay, let me solve it here. I said that we should calculate the coefficient of static friction. We need the normal reaction because coefficient of static friction or coefficient of kinetic friction, depending, is equal to what? The frictional force all over the normal reaction. So, but a body that is stationary like this, okay, a body that is stationary like this, the weight of that body is equal to the normal reaction, and the weight of a body is equal to what? Mg, mass times acceleration due to gravity, which is what? 5 times 10, which is what? 50 Newton. Okay, so we have gotten the normal reaction because the weight of that body is equal to the normal reaction. Therefore, coefficient of static friction is equal to the friction itself, which is 5 all over the normal reaction, which is what? 50, which will give you 1 over 10. 1 over 10. It does not have any SI unit because this is Newton against Newton. They cancel out. They can ask you a question. Why is it that coefficient of static friction or coefficient of kinetic friction does not have any SI unit? You will say that it is what? It is the ratio of similar quantities. That is why it does not have SI unit. It is the ratio of similar quantities. Okay? That is number one. So let us solve number two. See, it's very simple. All you need to know is just these two formulas. The first formula you need to know is that what? That coefficient of static friction or kinetic friction is what? The frictional force all over what? The normal reaction. This is the first formula you need to know. Then the second formula you need to know is that what? The moving force that will make it to move is equal to what? MA normally. And it's the same thing as saying the force applied minus what? The frictional force. So these are the only three, let me call it the only three formulas you need to know for friction. Then you are good to go. So let us solve the second question. The second question here said they gave us a body, and they said that this body is on this plane, and the body is 5 kg. Okay. They gave us that a pulling force of 40 Newton is applied. Okay, this is applied force, and then the frictional force is going this way, F. Okay, now let us read the question. They said a body of wood of mass 5 kg is pulled on a platform by a force of 40 Newton as illustrated in the diagram above, full stop. Okay, if the frictional force F experienced by the body is 12 Newton. Oh, they've given us that the frictional force, which is this F, okay, is equal to what? 12 Newton. Okay, and they gave us the applied force. The applied force is equal to what? 40 Newton. Okay, immediately you can get your moving force. The force that will make this thing move should be what? The applied force minus the frictional force, which is what? 40 minus 12, which is 28 Newton. Okay, we have gotten that. So let us continue with the question. They say calculate the magnitude of acceleration of the body. Calculate the magnitude of acceleration of the body. We know that moving force is the same as what? MA. And I've gotten the moving force as what? 28 is equal to, my M is 5 times the acceleration A. Therefore, my A will now be what? 28 divided by 5. And 28 divided by 5 will give us 5.6 meter per second square. You see, very simple. Frictional force is the simplest topic in physics. So let's continue. So the next question here gave us a force again. They gave us another body on this thing. They say that a force of 10 Newton applied and the frictional force is 1 Newton. Okay, very simple. They say that a body is acted upon by two horizontal forces as illustrated in the diagram above. The block accelerates at, they gave us the acceleration, accelerates at 1.5 meter per second square. Okay, calculate the mass of the block. Very simple. Calculate the mass of the block. We know that the moving force is equal to what? The applied force minus the frictional force. So let us get that. The applied force is 10 minus the frictional force. So I'm having 9 Newton. But the same moving force is then as saying mass times what? Acceleration. So I'm having 9 is equal to what? M times 1.5. So my M staying alone, I'm having 9 divided by 1.5, which will give us 9 divided by 1.5 will give us 6 kilogram. As simple as that. Very, very simple. Okay, so let us take the next one. Number whatever. Let me say number 4. I don't know. You can check your own. So they said now for number 4, they gave us this diagram now. And the body is on this. Okay, the body moves this way. Getting to this place has a roller like this. Then now come down. Now have a body here, Y. This is X. They gave us this one. And they said that here is 7.5 kg. And here is 5.0 kg, 5.0 kg. Okay? And they said that there is a frictional force here. They wrote it friction. Okay? Okay, and they said that this is a rough surface, please. Okay. Now write the question. They say two bodies X and Y of mass is 5.0 kg and 7.5 kg respectively are connected by a light inextensible string as illustrated in the diagram above. If X is placed on a rough surface, okay, on a rough surface of coefficient of friction, they gave us mu, coefficient of friction 0.5. okay, then I say calculate I calculate I, the normal reaction on X, I. Normal reaction on X, I. Frictional force on X, okay, I. Tension in the string, tension. Okay, tension in the string. Now this is a very simple question, very very simple. Now the first one said we should calculate the normal reaction on this. They gave us coefficient of static friction and they say we should calculate the normal reaction. Okay, now we need to get the weight of this body. And the weight of this body acts downward. Don't forget that the weight acts downward. The weight of this body is equal to what? Mg, which is equal to what? 5 times 10, which is what? 50 Newton. Okay, and for a body that is relaxing on top of something, the normal reaction is always equal to the weight. Please note that. So we've gotten the normal reaction as what? 50 Newton. Very simple. Very simple. The next one, they say calculate the frictional force. Oh, we know that mu is equal to what? Frictional force over the normal reaction. So frictional force standing alone is equal to what? Mu times the normal reaction, which is what? The mu they gave us is 0.5 times the normal reaction 50, which will give us 25 Newton. As simple as that. These people don't have question. I say the tension in the string. Now the tension in this string is here. The tension is what acts, this is the tension, and it acts directly opposite. Okay, this is the tension on this string. Now the tension on this string now, for this body now, this is the weight of this body acting downward. Okay, this is the weight on this body acting downward, and the weight on this body is equal to the tension here. The weight of this body is equal to the what? The tension here. Is that so? But let us calculate something. Okay, let us calculate something. There's something we need to calculate. That the moving force, the force that will allow this thing to move, okay, is equal to what? Is equal to the applied force minus what? The frictional force. Okay, and the applied force of this thing is what? The weight that is moving it downward. Okay, this is the weight is the applied force for this particular this thing here. The weight is this one that is pulling it downward, so which is mg. Okay, the applied force here is the weight, while the frictional force is this one that is opposing it, which is the tension. Okay, so we're having that fm. So fm is equal to the weight is mg minus the tension t. So mg is mass times, which is what? 7.5 times what? Times what am I saying? Times 10. Okay, minus t. Now the moving force, the force that will allow it to move, okay, the force that will allow it to move, I think in fact the tension on this body is supposed to be equal to the weight. Yes, the tension on that body is supposed to be equal to the weight there, because it's the weight that will produce the tension. So the weight is equal to the tension. So the weight is equal to what? So the tension is equal to the weight, and we know that weight is what? Mg, which is what? 7.5 times 10, which is what? 75 Newton. As simple as that. That is what it's supposed to be. Okay, so let's calculate the next one. Let me check my time. Okay, let's calculate the next one. Okay, the next one said number 5. It said a body, okay, a moving car of mass, the mass of this car is a moving car of mass 800 kg. This is the mass of this car. Experience a frictional force. They gave us the frictional force on this car, which is 200 Newton. Okay, they said a moving car of mass 800 kg experiences a frictional force of 200 Newton, full stop. If it accelerates at 2 meters per second, the acceleration there is what? 2 meters per second square. Okay, comma, calculate the magnitude of the applied force on the car. Calculate the magnitude on the applied force on the car. Okay, there is something you need to know. You need to know that what? The moving car, what will make this thing to move is equal to MA. And it's still equal to what? The applied force minus what? The frictional force. Okay? So what do we have now? Am I missing anything? Okay, so we are going to get the applied force. What do they say we should calculate? Calculate the applied. Okay, we are looking for the applied force, but we know that this is MA. So the mass, which is 800 times the acceleration is what? So they say acceleration is what? 2. The acceleration is 2 meters per second. So 800 times 2, which is this MA, is equal to the applied force minus the frictional force, which is 200. So this and this will give you 1600 is equal to what? FA minus 200. Collect like terms. You're going to have that FA is equal to what? 1600 minus 200, which is equal to what? 1800 Newton. As simple as that. 1800 Newton. As simple as that. Okay, the next one said a body of mass 25 kg. A body of mass 25 kg. Okay? Moves at 3 meters per second. They gave us the velocity now, not acceleration. 3 meters per second. Sorry. 3 meters per second. Okay? Let me read. A body of mass 25 kg, moving at 3 meters per second on a rough horizontal floor. Okay? It's brought to rest after sliding through a distance of, they gave us the distance before bringing it to rest, distance of 2.5 meter. Okay, 2.5 meter on the floor. Then calculate the coefficient of static friction. Calculate the coefficient of static friction. Okay, first of all, we know that the weight of this body must be equal to the normal reaction, and the weight of body is mg. Okay, which is equal to what? 25 times 10, which is what? 250 Newton. Okay, we have gotten the normal reaction. So what is remaining now is the frictional force. The frictional force is what is remaining. Okay, so but there is something we are going to do. Okay, we need acceleration to get the moving force. We need to get the moving force, and the moving force here should be equal to, what am I saying? Okay, first of all, let us get acceleration. Let's use the equation of motion. We have that v is equal to u plus at. There is no time. We know that v squared is equal to u squared plus 2as. Okay, this one will help us. This one will help us. So we have that v squared. Okay, since it's brought to rest, the final velocity is 0. Since it's brought to 0 meter per second, since it is brought to rest, so I'm having 0 squared is equal to 3 squared plus 2 bracket minus a. Then the distance there is what? 2.5. Why did I use minus a? Because it is retardation. Coming to rest is retardation. Okay, so I'm having 0 is equal to 9 minus 2.5 times 2 will give you what? Let me do 2.5 times 2. Pardon me. 2.5 times 2. Okay, so I'm having 5. So this is 5. 5a. So collect items to have that 5a is equal to what? 9. So a is equal to what? 9 over 5 meter per second square. Okay, that is that. So now the moving force there is supposed to be what? So let us get what we need. The moving force is what? MA, which is equal to what? MA is equal to mass 25 times what? 9 over 5, which is equal to what? 5 times 9 times 45 Newton. Okay, 45 Newton. So what do we do? Okay, so now we know that coefficient of static friction is equal to what? Frictional force over what? The normal reaction. frictional force over the normal reaction. Sorry, the normal reaction. Okay, and we know that moving force is equal to what? Applied force minus minus, what am I saying? Minus frictional force. Okay, so but in this case there is no applied force. If there is no applied force, it means that the moving force is equal to the frictional force. If there is no applied force, they don't tell us that it's being applied by a particular force. Okay, so we are going to have that the coefficient of static friction is now 45 divided by 250, so which will give you 0.18, no SI unit. Okay, so that is that. Okay, so the next question. Now remember that all these things we have been talking, I should have drawn it, sha. All these things that we are doing is for objects that is lying on a plane. Okay, a horizontal plane. So now let's talk about objects that is lying that is lying on an inclined plane. Objects that are lying on what? In an inclined plane. So let's have this. If I have this now, this is inclined at an angle theta, and I have an object here. Watch you, please. Very, very important. Now the weight of this object acts downward. This is the weight, and the normal reaction still acts upward. This is the normal reaction. Okay, now this is the applied force. This is the applied force because we want it to go down. This is the applied force. While frictional force is taking it what? This is the frictional force taking it up. Okay, because the moving force is going to overcome this, so this thing will still come down. So we are going to have the moving force here. This is the moving force. Now there is something I need you to know. Watch out. The normal reaction, listen, the normal reaction, okay, is the reaction on this thing that will make this thing to remain on this body. Now this normal reaction is acting vertically downward. That is what will make this body to remain on this plane. It will not allow it to slide down. That is the normal reaction. It is a reaction that is pushing it to, as the weight is pulling this thing like this. So the normal reaction is what is keeping it on that plane. Are you getting it now? And if you look at it, for this thing, for this object to remain on this plane, it means that this man is supposed to be coming down. And as it's coming down, that is what will make this thing to remain here. Okay? And don't forget that your all St. Teresa's College, don't forget the very, very important. Now, if this thing should come down, for this thing to remain, for this this object to remain here, that is what is the normal reaction saying. Okay, is the coming down towards this angle or opposite the angle or against the angle. You see, it is towards the angle, and they say that towards angle is cos. That is why we have that the normal reaction is the weight cos theta, because towards the angle is cos, and the weight is equal to what? Mg cos theta. You see how we got this formula. Now the next thing we need to get is what? The frictional force. The frictional force. Now the frictional force here is the force that is going to make this thing in fact, is the force that is going to make this thing to, in fact, it's the horizontal force, is the force that is going to make this thing to do what? To go up like this. As you are moving it, even if you are pushing this thing upward, even if you are pushing it upward like this, or pushing this one downward, any of them, this and this is the same. If this thing is going to slide down, okay, because we know that this is bigger than this, it's going to make this line, this plane, to go upward, because as this plane is going upward, this one is sliding down. So since it's going upward, is it towards the angle or against the angle? That is what I want to ask you. You see, it is against the angle, and against the angle said we should use what? Sine. So it's going to be what? W sine theta. Okay, so which is what? Mg sine theta. Okay, so from this place we know that our coefficient of static friction or kinetic friction is what? The frictional force all over what? The normal reaction. And the frictional force is what? Mg sine theta, okay, all over Mg cos theta. Now if Mg cancel Mg, I'm having sine theta over cos theta, and sine theta over cos theta is equal to what? Tan theta. Okay, so you should know that what? That mu is equal to tan theta. Another important formula. Now, for an object that is sliding downward, these are the formulas you need. 1, 2, and 3. Okay, I hope you understood how I explained it. Okay, so let us solve some questions for you to understand it very, very well. Now, the first example they gave us, they drew something like this, inclined at an angle of 30 with a body like this, and the body is 5 kg. Okay, now the question said, from the diagram above, find I, the force to the plane. Okay, sorry, the force parallel to the plane to slide it downward. The force parallel to the plane to slide it downward. So the force that is going to make this thing slide downward here is my moving force. And if this thing is going to slide down, it means that this man must be moving up. And if he's moving up, is he against the angle or towards the angle? You see, is what? Against the angle. So against is sine. So it's going to be what? mg sine theta. So which is equal to what? My 5 times 10 sine 30. Which is what? 5 times 10 times 0.5. So I'm going to have 25 Newton. Okay? We've gotten the first one to be 25 Newton. Now the second one is now the normal reaction. The normal reaction. II. Now for the normal reaction, they say we should get the normal reaction between the surface. Don't forget that the normal reaction is what is going to make this to remain on this. And for it to remain on this one has to be coming down. And if it's coming down, it's going to be what? Towards the angle. And towards the angle is cos. So mg cos theta. So which is what? 5 times 10 times cos 30. Which is what? 50 times root 3 over 2. Okay? So which is what? 25 root 3 Newton. 25 root 3 Newton. So the next one they say we should calculate is the next one they say we should calculate is what? The coefficient of what? The coefficient of friction. And the coefficient of friction is mu. And mu is simply tan theta, that's all. Mu is simply tan theta. I. Mu is simply what? Tan theta, which is what? Tan 30. And tan 30 is what? 1 over root 3. Which is center what? Root 3 over 3. That's all. Okay? Okay. So, thank you very much. Let's solve one more question. Okay, maybe in our next video we'll solve more questions. So, thank you very much for watching.